Hi, I'm following along with Paul McWhorter's Arduino with Python lessons. We're on number 6, and our homework this week was to um, do something more with the analog meters that we have been working on for the last couple of weeks. So my idea was, well, if 1 meter is good, 2, 3, or 4 meters is even better. So I had already uh, created a class for several things, including my thermometer bulbs you see here. And I actually did it for the clock face that when we were working on clocks as in the VPython classes. So I said, well, let's make a class for the meters. I knew it was going to be a little harder. While I wanted to keep the size and the shape and the basics of the meter the same, I wanted to be able to change its position on the screen, and I wanted to be able to change the graduations on it so that you could tell, put different types of graduations, and also the number of graduations. I wanted to be able to change that as well, major tick marks, that you have on there. And also, you'd want to be able to change the label to tell you what the meter is measuring as well. So I did all that and got it done. And I figured, well, that worked out pretty well. Um, Now, what kind of project can I put it in? So yesterday afternoon, I was spent a couple hours working on a silly simulation project that incorporated my meters as well as uh, got a lot of practice making other things with VPython. So we'll give a little quick glance of what it's doing. So it's sort of a simulation of a heating system, I guess, with a boiler and a pump and a fan going over a radiator. So I can say the radiator, it turned out kind of cool. I was able to create the whole all the fins on this radiator with one line of VPython code. So I'll show you that when I get to the code. But kind of cool the power of Python once you get to learn about it a little bit more. So anyhow, code turned out it ended up being about 150 lines, but as you can see, I got 3 of my meters and classes here, and as you can see, one's in gallons per minute, and it goes from 1 to 4. And I got RPM for the fan, and it goes from 200 to 1200. And over here, volts DC going, I'm heating my boiler water with electric. So we got amount of volts DC going into it, and I got from 0 to 500 on that. So, and that's hooked up to the Arduino with the 3 pots. So we did a couple lessons back to show how 3 pots you could use multiple potentiometers and get the information in. So anyhow, it was kind of fun. So we'll get to the code a little bit, I guess would be the best thing to do next. So this is the top of the code. We have to import our library, serial, and time for interacting with the Arduino, and then VPython and NumPy for doing our VPython stuff. Got some parameters here. You might want to come back to this screen after you watch it. I got an exit question at the end if you're interested in answering it, and you'll need to come back at this point to find some of the parameters that I used in my exit question. So our class here is, I called it analog meter, a meter. I like to keep my names as short as I can when I'm making things. So we're initializing it. Of course, you have to have self if you're doing multiples. And M position is actually a vector. So it's an X, Y, and Z. So that's where you're going to place it. And um, as I said, I wanted to have different scales. So I thought, well, you could put a first and a last and then divide it. And then, well, a lot of times your divisions don't end up being where you want it to be and everything. So I decided just to make a list of numbers for the scale. So if you want 0 to 5, you put 0, 1, 2, 3, 4, and 5 in your list as list items. And then, or if you wanted 0 to 7, you could say 1, 0, 1, 2, 3, 4, 5, 6, 7. So you're going to use the length of the list as well so that you can work with your lens space so you can divide your meter up correctly and everything. And then I also added the height of the numbers on the scale. I found that if you went like with thousands or hundreds or whatever, that you might want a different size than you did if you just had 1, 2, 3, 4, 5. And then that's just a number. And then our label is a text object that we're importing in. So to create each one of our list meters, all you have to do is import one line of code, and you can have as many meters as you want. So we can talk about a little bit. I'm not going to talk a whole lot about this, but we're doing getting our self. So we're importing our stuff that we're getting in, and a lot of it's the same. So to get the position on our things, anywhere we had a position, I added plus self dot position to it. So whatever we did to get the meter, and then you're just going to adjust it all, each one of these, you can see self dot position, self dot position. So you got all those. So that's how we're positioning on the screen. You're adding vectors, which worked great with VPython. And then our scale list, we're just iterating over it. And we're in, we were doing our count in the past, and we, just add one to it. So our count now becomes our list, which entry it is in the list. So we're using our count to go to iterate through the list as well. And then the size of the text, wherever that is, yeah, scale.h, we need the size of text. And the text itself on the meter. Oh yeah, it's up here. So it's called an M label. So when you put the text to what your meter is actually measuring, that's there. And that's, it's just basically what we went through to make 1 meter. We changed a lot of stuff to self, and then we had to make a few changes so that we could import our list. Like I said, the lens space, we're using the length of our list and doing a little bit of math to get the right number. Remember, we had to have it +1. And then these are the minor ticks. So I just settled that all the lists have 5 minor ticks in between the major ticks. That's 5 spaces. So that's made it a little easier. I didn't have to worry about figuring out minor ones. And then when we're ready to read it, all we're doing is I call it the pointer up here. Let's see, where did I put the pointer? Oh, it's right here. Yeah. So we're putting our pointer arrow on the screen, and then we know the vector and everything. We got that all figured out, and that's going to be the same. But then we just adjust the vector when we get a value in, we have to have a self and then value. And here's my map this function. So that I ended up calling this 6 different times each loop through the while true. So it came in handy to have a function there for sure. This is our Arduino startup. Now we'll talk about some of the parts that we put on the, well, actually, let's go down to the, where are we setting up our meter? So to call a meter, all we're doing is calling the instance of a meter, and we're inputting a vector, a list of the major graduations, the size of those graduations, and then our title for our meter. So one line of code creates a new meter each time, and we got 3 meters, and you say different scales, different numbers, and like you say, there's quite a few there. There's different number here, different number there, and different things, and all worked out really well. So that was good. And then we'll skip these 2, but we're doing a rate of 30. But like I said, we are animating our fan and pump motor vane. So I did definitely need a non-blocking. We couldn't be sitting here waiting for the Arduino to send something. So this is the non-blocking style of waiting for a read. And then we're just getting our data and decoding it and changing it to usable. We're splitting it up. I split mine on the colon. So we're ended up with 3 values, and then each value is for a different meter. So, but we're mapping it. All of the meters are the same. They got that 4/5 to 1/5 pi, and the inputs are going to be all 0 to 1023. I didn't do any conversions on the Arduino. So these 3 are all going to be the same, and they're just going to, that's just putting it on the, putting the arrow in the right spot, mapping the arrow placement actually. And it's really disconnected from our actual data values, just the way it works. So, but then we're doing a separate map this for the gallons per minute. So it's still a 0 to 1023 coming in, but then we put our range of the minimum and maximum of our meter, and the first number and the last number in our list, basically. And so same way down here we're doing, and like I say, we're just doing the data. We got 3 pieces of data in a list, so we're just pulling 0, 1, and 2 out. And this one was 200 to 1200, and this was voltage was 0 to 500. And so then we got things that we can use to calculate with, so that worked out well on that. So before I get into the math part down the bottom, I'll just real quick go through how I created all that, everything you see up there. So I didn't know much about extrusions, but I did some playing around with extrusions. I said, oh, this is kind of cool. And then they talked about, making your shapes, and you can make multiple pieces of it. And I said, oh, if you remember last week, I just learned about the list comprehension thing, where you can actually put a for range inside of this. So, and then iterate and use your index for to change something in your shape that you want. So this is actually changing the position of the shape on the thing. So, and I'm doing it 25 or 0 to 25. So doing it 25 times, and so I'm getting 25 of these ellipses, and then the path is where you pull them into an extrusion. So that's kind of cool. We're going 0, 0 to 27. So we're going in the Y direction, 27 units tall. And one cool thing I read up when I was reading about extrusions is you can actually do a color change where you can do a fade. So the 0, they correspond to this. So the 0, 0, the bottom one is color red, and the 27 is color blue, and then they kind of just fade in between them. I think you probably saw that. When we go back to it, you'll see that as well. So that's kind of cool. All those fins and everything was just one line of code. Kind of fun when you can get away with doing something like that in Python. You don't have those kind of things in C++, or at least I don't know much about them if they are coming from that world. So we got all this piping. If you noticed up there, our piping, I tried for a while to figure out how to do elbows, but I couldn't figure it out. So I just kind of butt the pipe up to one another. So, and rather than doing, I couldn't figure out, you can do an elbow, but it's like 4 or 5 lines of code for each one. And there's probably 6 or 7 or 8 of them up there, elbows. I was like, well, I'm not going to do all that. So it looks like I'm using T's instead of elbows, but that's all right. And they're just different positions for each one's a cylinder. They're all basically one radius of 1. We got some down here. I had flanges that I had there, but then the boiler was just a cylinder in a box, and I used the metal textures to make it look metal. And the box, I just use a red stucco. I look for brick, but I couldn't find red brick. Kind of like those old boiler toys you used to get. Put the little pellets in way back when I was a kid. And then the blower. If you noticed, I had the fan blades. So that was kind of fun. I got to go back to my clock. When we were doing the clock, I made like the sunflower clock where you put sunflower petals behind it. And I had learned how to make ellipses and tilt them. And had no idea that, okay, well, I can use those for fan blades. So I just made the ellipses a little different shape and created fan blades out of them. So that's kind of cool. And just put the blades together and added the other parts of it. And this I actually put into, after I appended all the parts, I put it into a compound. I felt that was the easier way, and then just rotated it where I needed to put it. So that worked out for that. So, and then I think the motor actually is a separate, it's not part of the compound. So the motor for that. Did the exact same thing for this is actually for the water pump. The vanes of the water pump are tilted almost 90 degrees, I think. So look like more like something that's going to work and make a centrifugal pump. So, but I did that, different size vanes and everything, and used in a different parts here, but everything's pretty much the same. I just made my pump a little bit see-through so that we could, so you can actually see it spinning since it's enclosed in a case. I just made the case see-through. Yep, so we did that. And then, so if you notice, there's a thermometer on there, so that gets into our calculations. So if you're going to have a simulation, I said, well, we can adjust the 3 potentiometers to get one for voltage to the amount of input we're getting into our system of heat, and then combine the fan and the pump RPMs to give a little unrealistic way of quantizing the amount of energy that we're getting out of our system, the heat we're getting out of our system. And that way we could use a thermometer to keep track of, you know, what the temperature of the boiler or the boiler is. So we did that, and so I created a thermometer. So it's pretty similar to the other bulb thermometers that we were having, with a red inside and a white outside. So looking like a glass tube with fluid in it. And most of the parts we didn't need to name, but since we're going to be adjusting the red fluid level, we needed to give it a name here. That worked out. And just a box around it. And then wanted to put tick marks on it. I didn't go to all the trouble of labeling them with numbers, so I just put tick marks on it. And then I had so much fun with the other extrusion, I said, well, let's make an extrusion with our colors on it. So now we're going at just a single ellipse that we're extruding the length of the thermometer gauge on the other side. And this time we're just giving it 3 vectors, 3 different path points. And that way we can give it 3 different colors. So we got green in the middle and blue on the cold end and red on the hot end. So that just made a little thin ellipse. We'll get over that when we do it. And that's my meters, and then the wall true. So this is our, I'm going to leave it here for a second because you'll need to come back to this when I ask my question a little bit later. But this is the calculations we're using to get our system net, whether we're losing energy, whether we're losing heat or gaining heat. I guess you could call it imaginary heat units or something that we're, or whatever. But it's just fun numbers to play with. And then we're coming up with a number between -1 and +1. And if you were tending this boiler on a ship or something, you'd probably want to keep that at 0 so it didn't get too cold or too hot, so that we don't lose any heat when we're doing it. Get your temperature up to a certain point and try to keep it there. Of course, the computer should take care of that these days, but this is a simulation, so we're not letting we're letting the human control the things. And basically we're just updating the thermometer, the bulb, the red fluid in there by doing it like that. And this is just constraining it. We don't want it to go above and we don't want it to come below our numbers. Our scale starts at 3 and ends at 19 in our screen world up there. And this is just something to print what our system net is. So it's going to be between -1 and 1 is what's going to show up here. So that's basically the code. So like I said, you'll probably want to come back to this part when I ask my question, if you feel like answering it. If you do, feel free to do that in the comments. So let's see. We'll go back to our system. So you can see right now that I got the system. This is the readout that showing what the net heat in and out is. So I just played around with it just to keep our thermometer, and you can see our thermometer is in the right place. So let's see if I can move this around. So you can say this is the little ellipse I have that starts out blue, goes through green, and then the red. Let me see if I can tilt it down. You can see it's just an ellipse that's in there. Hard to tell. It's just a thin little ellipse, just like a raised thing on the thermometer bulb. So, but anyhow, trying to keep it in the green here. So that's what we're doing. I can adjust our volts and everything, and let's back out a little bit here. Slide back over. All right, so you can see we're at about 2 gallons a minute, and 600 RPMs on our fan. I just have these running. I didn't try to adjust the speed to correspond to that. I tried it actually, but all you're doing is, sometimes they look like they're going backwards. They're both supposed to be going the correct way, but even right now, the pump looks like it's going the backwards. But I think that's just the way the math works on that. We're definitely trying to do it the other way, but let's see, we can see most of them now. So if I increase the voltage, let's see if I can get it to come down a little bit. There we go. If I increase the voltage, you see that we went into positive. We're making more heat than we're getting rid of with our system. Like I say, that should stay between 1 and 0. And so we're doing that. So as you can see, these never stop here. So the way it is, if I go to 0 volts where we're not putting any energy into it, and I slow the fans all the way, the pumps, got a sticky thing there. Sticky potentiometer. All right. That one likes to jump a little bit. But you can see that we're actually losing. I mean, there wouldn't be hardly any flow and hardly any RPM. So, but this tank is eventually going to lose heat. And with the calculations, this is eventually going to go down, down, down eventually. And bottom out at the bottom here and stay there at the bottom of the gauge. So you've seen it working. And like I said, so my question is, and I'm going to raise it back up a little bit so you don't see the answer. My question is if we have full voltage, full RPM, and full pump speed with gallons a minute. So you saw my calculations, and if you go back to the beginning, you can see my parameters that I put in. My exit question for this video is, with everything at full like it is now, is this system going to gain heat, gain temperature, lose temperature, or stay exactly equal? So that's my question. And it's been a fun little project to make. I probably spent four hours of my time on it between yesterday and this morning getting it done. But it's been a fun project, and keep learning a lot from Paul and enjoying everything he does. So feel free to put your answer in the comments. I'm interested to see. It's not that hard of math, but you got to go. It's like a scavenger hunt. You got to go find out what I use for my parameters, basically, and then what the top numbers are. They're 1200, 4, and 500. So that's your numbers that you're going to need to use. All right. Well, it's been fun. Thanks for watching.